Okay, guys, we're going to hit the last part of 3.2, Chebyshev's theorem. So, going back to what we were talking about, we talked about the empirical theorem. Let me go through this. And that was estimations. Hold on, it's not doing. Hold on just one second, guys. Okay, so we're talking about, hopefully it'll bring it up for me. Okay. It's Chebyshev's theorem. Okay, so what we're talking about is, remember with the empirical rule we were talking about bell-shaped data? Well, now we're just talking about any kind of data. I'm going to tell you this now. This is not it's not a very well-known or used theorem because it kind of, you can punch holes to it when you start looking at data. So what we're going to say now is we're just looking at any other kind of data other than bell-shaped. So we're going to say the proportion of data that lies within k standard deviations of the mean is at least 1 minus 1 over k squared for k greater than 1. When k equals 2 or 3, it says that k equals 2, then at least 75% of the data lie within 2 standard deviations of the mean. If k is 3, then we say 88.9% of the data lies within 3 standard deviations of the mean. So let's look at it. Suppose that in one small town, the average household income is $34,200 with a standard deviation of 2,200. What percentage of the houses earn between $27,600 and $40,800? Since we're not told where it's bell-shaped, we can't apply the empirical rule, but we can make an estimate for it. In order to do that, we need to know how many standard deviations 27,600 and 40,800 is away from the mean. By subtracting it, we can find out how far the figure is from the mean. And then by dividing by the standard deviation, we can convert it into the standard deviations. Okay, so let's look at it. So what did we do? We subtracted 27,600 minus the 34,200, and it equals negative 6,600. We divide that by 2,200, and we get negative 3. And then we can do it for the same. It's very similar to what we did with the empirical rule. So then we do 40,800 minus 34,200 equals 6,600. Divide that by 2,200, we get 3. We know based on the rules of the theorem that 88.9% of that data lie within that. So remember, you're using the standard score or the z-score for that, which is the data value minus the mean over the standard deviation. This is very similar to the empirical rule. You're just using that if your standard deviation is 2, it does 75% of the data. If it's 3, then it's 88.9, or at least that. Hope this helped. Thanks.